Okay, so today is all about graphing. So we're doing these on our graph paper. So make sure that you have graph paper to graph these on. If you're watching this at home, you can put notes on notebook paper, but homework needs to be on graph paper. So we want to graph, describe the transformation, and state the domain and the range. All of these problems you guys can put on your graph paper. Actually, all of the notes today, if you want to put on your graph paper, you can. But if there's some things, if you want to put on notebook paper, you can do that too. So go ahead and write down those instructions and then just write down the first problem, y equals square root x. Also, when we graph things, we graph all of them on different xy axes. We're going to start off graphing these different ones here. So they're all going to be on different, don't make one big x-axis and put them all together. Graph them all on separate little ones. Size-wise, you can probably just go, make sure you got 5 at least in all 4 directions, up, down, left, right. Before we really get started into this, we need to talk about these last 2 words down here, domain and range. You may have heard those back in Math 1, but do you remember what they are? Does anybody remember what domain means? That is correct. Your domain is all possible x values. So if you don't know that, make sure you make a note. All possible x values. If you're looking at a graph, you can think about how far the graph goes in the x direction. So which way does the x-axis go? Yep, it goes left to right, right? It goes kind of horizontally. So you're looking at how far the graph goes left and right. So if that's the domain, what do you think the range is? All possible y values and how far the graph goes up and down. So domain is looking left to right, range is looking up and down. When you get into Math 3, we talk about domain and range a lot for all different kinds of graphs. We look at linear and quadratic and cubic, any kind of polynomials. Then we look at what we call absolute value graphs and rational graphs, all kinds of stuff. Okay, so your domain is all the possible x values that you could plug into the function and get out a real answer, and how far the graph goes left and right. And your range is your y values, so how far the graph goes up and down, but all possible values that you can get out of the function based on those x values. So let's look at our first one that we want to graph. We want to graph y equals square root x. Now, first thing you should probably do is just graph it on your calculator. Let's see what it looks like. So go to y equals. If you have anything in there, make sure that you clear it out. If you have one of these stat plots that are highlighted, go up to it and hit enter on it and make sure that's not highlighted. So everything should be blank and not highlighted. And then you hit your square root button and hit X. Now, to make sure that we are all looking at the exact same picture, you can make your calculator go to what we call the standard window. So once it's typed in, you hit zoom and the number 6. Zoom 6 is the standard window, so it's going from -10 to 10 on your x-axis and your y-axis. So this doesn't look like a line. It looks like kind of like a curve, almost kind of exponentially looking, but it has a place where it starts. So if you look at this graph, where do you think this graph starts at? 0, 0. That's right. It starts at 0, 0 at the origin. So what I want you to do is put a little dot there at the origin on your graph paper, and then All you have to do is make that shape. You don't have to plot any more points. We're just going to do this as basic as we can. So we put the starting point, and then it goes up and over, and eventually it looks like it levels off, although it gets slightly taller and taller as it goes through. It kind of looks like a parabola, but half of it on its side. So if you think about a parabola or quadratic, it's on its side and it's just half. Now, any transformation talks about any way that it moves. This one is actually called our parent function. There is no transformation that goes along with this one. This is as basic as it gets. It's a square root. It's an x. There's nothing added to it, nothing subtracted to it. So that's our basic function. So that one has no transformation. But now we want to state our domain, which we will call D, and our range. So with domain, it's all the possible x values, but it's also how far the graph goes left and right. Well, this one has a starting point, right? This one starts at 0, and then it goes which direction, left or right? Right. So our x values start at 0 and then goes to the right. When you think about going to the right, you should think about numbers that are getting bigger once you go to the right. So we say x is greater than or equal to 0. They start at 0 and then they keep going. Similarly with range. Range is our y values. Now range is how far the graph goes up or down. Well, once we start here at 0, the graph goes up. So we would say y is greater than or equal to 0. And that's all that you need to do for that one. Make a short graph, state domain and range, and describe any transformation if it has any. So let's move on to problem 2. Absolute value of x plus 2. Now look at that plus 2. Is it under the square root? No, it is not. All right, so what we should do first is graph this on our calculator. Bless you. We're just going to graph the first ones to kind of see what they look like, and then we'll notice any patterns that we have. So once you have your square root of x, just right arrow over. Make sure you're out of that square root, and then hit a plus 2. So make sure that plus 2 is not in the parenthesis or under the square root, and then hit graph. Well, what happened to that graph? It moved up 2. This is called a vertical shift. So our graph shifted vertically up 2. But all you have to write is up 2. That's how you would describe the transformation. The whole thing moved up 2 units. Now, do the same thing on your graph. You've got your XY axis. We'll go up 2 and put a dot. And then the graph went up and over. Is it working? Do y'all need help? Okay. Oh, okay. So here's our graph. Up 2 is describing our transformation. So now we want to state our domain and range. If you think about where this starts and maybe writing that point as a coordinate, that can help you with the domain and range. So what's the starting point at? 0, 2. Good. The x value is 0. The y value is 2 because we just moved up 2. So 0, 2. That number can help you do your domain and range. So domain is your x value. So my x value starts at 0 and it's going to the right. So I would say greater than or equal to. Good. And my range is no longer starting at 0, but it's starting at 2. So y is greater than or equal to 2. Because it starts at 2 and goes up and over. What do you think would happen instead of a plus 2 here at the end? What if it said minus 3? That's where you start the y value. So it would shift down 3. So whatever number's at the end makes it move up or down. So if it's positive, it moves up, and if it's negative, it moves down. Now, the next one, we have a 3 under the square root. So let's figure out what that does. So y equals square root x minus 3. Now, first, we should probably graph it in our calculator. So I'm just going to clear that out and do square root x minus 3, but now I want to make sure my minus 3 is under the square root or in the parenthesis. And now I hit graph. Well, what happened to that graph? It went over 3 to the right. It moved right 3. Would that be what you would expect it to do with a minus 3? Most of the time we think it's a minus 3, so it should move what way? Left. It moves the opposite when it's with x. So when it's with x, it's going to move left or right, opposite of what you think. And that happens with every type of problem that you have, every type of equation. If it's with x, it moves the opposite direction. So this one, we're going to move right 3 and put a dot, and then make that curve going up and over. What are the coordinates of this point? 3, 0. Yep. The x value is 3 because it moved right 3, but it didn't move up or down any. So our domain would be what? Good. And our range? Y is? Very good. So let's write down just a little cheat sheet over here to help us. We can say transformations. That's kind of like a little title. If you have y equals the square root of x plus a number, so that plus a number is outside the square root, that's going to make it move up. If we have y equals square root of x minus a number, it's going to make it move down. If we have y equals the square root of x plus a number on the inside, so now it's plus on the inside, it's going to move which direction? Left. And if it's minus on the inside, it's going to move right. So remember, if it's with x, it's opposite of what you think. There's 2 or 3 more things that we'll add to this list, but you can kind of keep that to the side. That'll help with the first few problems that we do. So up, down, left, and right are describing our transformations. And you can have a combination of those. So you can have 2 of those at the same time. And let's see what happens and where our graph moves. So if you think about it starting at 0, 0, that's your starting point because that's the parent function. Then where does it go from there? So this next problem, let's do it without graphing it on the calculator. So this one says y equals x plus 2 minus 1. Now, without graphing it on the calculator, let's graph it on our paper, okay? So the plus 2 inside the square root tells us what? Left 2. What does this minus 1 tell us? Down 1. So just do that on your graph. Move left 2, down 1, and put a dot. That's where you're going to start, and then make that curve going up and over. It doesn't have to be exact. The only point that I'm going to look for that's exact is that starting point. So left 2, down 1, make a dot, go up and over. What are the coordinates of this point? Good, -2, -1. So remember, if you can write down those coordinates, you can tell me the domain and range. The domain would be x is greater than or equal to -2. And the range? Very good. So see how we could do that problem without graphing it on our calculator? Just look for the numbers. If they're with x, it's left or right, opposite of what you think. If it's at the end, it's up or down, exactly what you think. All right, now we got another one to graph. What if we have y equals negative square root x? Now this one we might want to graph on our calculator just to see, hey, what does this look like? So let's go into our y equals. I would just clear out what's there. Use the negative button that's down here at the very bottom. And then square root of x. And then you can just hit graph. So what happens to the graph? It goes down. Instead of up and over, it goes down and over. But it's still going to the right. It's just going down. So what happens when we put a negative in front there? Well, it flips it. Or another word for flip, think about that transformation unit that we did. It is reflected. And it's reflected specifically over the x-axis. So you need to add in all those words. When you have a negative at the beginning, you need to say it's reflected over the x-axis. So this one still starts here at 0, 0, but it goes down and over to the right. So your domain and range. Now, it still starts at 0, 0. So for these, you have x and y. You're going to have 0 and 0, but your symbols tell the direction which it goes. So if it starts here and goes to the right, just like the other ones, it's still greater than or equal to. But now the y values are now going down, so it's going to be less than or equal to. So if you see that negative there at the front, then this sign is going to be less than or equal to. Let's talk about square roots real quick. Can I type in the square root of -4 in my calculator? Can I take the square root of a negative number? No, right? It doesn't work out. If you try to type it in, it would give you an unreal answer. So we cannot use negatives under our square root. So that's why this graph will never go this direction, because all of these would have to give us negatives under our square root. So it never goes to the left. It will always go to the right. The only part with that negative is it opens down because it gets reflected. Okay? So your domain will always be greater than or equal to. All right, let's practice some more problems. So why don't you guys just practice those top two? Do those two on your paper. See if you can figure out the domain and the range and try to make a graph. We'll do them together in a minute, but I'll give you a chance to practice. Okay, guys, y'all had a chance to try these, so let's see how you did. If you don't have them done, it's okay. We'll just go through them together, too. So, how would you describe the transformation on this first one? It goes up 2. Very good. It caused the plus 2. That's right. And what about this right here? Good. Reflected over the x-axis. So, yeah, it will end up flipping and going down, but to describe it, we need to use that phrase, reflected over the x-axis. So, the first thing that you want to do is move up or down or left or right. So, this one, we're going to go up 2 and make our dot. Then, the reflection tells us instead of going up and over, we're going down and over. So, that's what our graph should look like. It moves up 2, but then it goes down and over. So, what are the coordinates of this point where it starts at? 0, 2. Good. So, remember, that is your domain and range value. For your domain, we would say x is. Good. And the range, y is, since it's reflected, less than or equal to 2. Any questions on that one? Okay, let's try our next one. It's a little bit more difficult. We got a few more things in there. So if you want to read through it, it starts out y equals negative. Well, when we see a negative, what do? Reflects over the x-axis. Then I have the square root of x minus 3. What is that minus 3 telling us? Good. It moves to the right 3. And then a plus 2 means it moves up 2. So think about how it moves left, right, up, down first. So we're going to move right 3 and up 2. But then it's reflected, so it goes down and over. What are the coordinates of that point? 3, 2. So our domain is x is, and the range. Very good. So we're using that point 3, 2, or using it from up here, right 3, up 2. They just go right in there for a domain and range. And remember, it's always greater than or equal to unless it is reflected. All right, so what happens on problems like these where now we have a number in front of that square root? What is that going to do to the graph? So let's look at y equals 2 square root of x. So on this one, to kind of see that change, we need to look at the graph of it. So let's go to our calculator. And in y equals, let's clear that out. And let's go ahead and just type in the regular square root x, though, in y1. And then in y2, we're going to type in 2 square root x. Now, let's hit graph. Now, the first graph that was made in mine, it's that blue graph, is our original function, y equals square root x. So what does the 2 do to the problem? It makes it go higher. So we call this a stretch. Now, you have 2 types of stretches. You have a vertical stretch or you have a horizontal stretch. What would this one be? It would be a vertical stretch because it stretches it up to go higher. Good. So this one, when we describe our translation, it has a vertical stretch of 2. Now, where does it start at? 0, 0. And that vertical stretch is just going to make it go taller and over. That's the only thing that you're going to change. You don't have to plot extra points. Just make it look a little bit taller than the other ones that you did. So if I'm talking about domain and range again, my domain would be 0 and the range. Good. So does the vertical stretch affect the domain and the range? No, it doesn't affect it at all. It just affects how tall that you make it. All right, now what if we took that number and changed it to a 1/3? So let's go back to our calculator and change that to a 1/3. So I'm going to get rid of that. I'm going to insert my 1/3 there at the beginning. You can do it in parentheses. You could clear it out and then type it in again, whatever you need to do. And let's look at that graph. Now we're looking at the red graph is the new one. So what happened from the blue graph to the red graph? It got a lot shorter. So instead of a vertical stretch, now it's a horizontal stretch. So it stretches out this way. So this one has a horizontal stretch. Of 1/3. Make sure you put of how much it is. Well, not necessarily. So let's think about what the magic number is to help us figure out if it's a horizontal stretch or a vertical stretch. So this is something to kind of add to that list if you wanted to. So if you have a number in front of x, if this number is less than 1, it is a horizontal stretch. Because less than 1, you can kind of think about that like a slope, right? Remember how we do slope, rise over run? So we'd go up 1 over 3, up 1 over 3. It's kind of going to stretch it out long ways. But if this number is more than 1, then it is a vertical stretch. Because that makes it go up higher. It's like a slope of 2. So we go up 2 over 1, up 2 over 1. So it makes it more steep. So if you kind of think about it as slope, you can get the right idea. But less than 1 is a vertical stretch, less than 1 is a horizontal stretch, more than 1 is a vertical stretch. Now if it just equals 1, it's just like your parent function that you had at the beginning. And I guess we could add on here, if it's negative, you have that reflection. All right, so let's make the graph of this one. Again, it's going to start at 0, 0, and we're just going to make this one shorter. So just make it kind of a little bit shorter than you've made the other graphs before. Now, domain and range, is it going to change from our last problem? No, because there's nothing added or subtracted, so your domain and range are both greater than or equal to 0. So we've talked about all the different types of translations that you can have. Up, down, left, right, horizontal stretch, vertical stretch, and reflection. So there are 7 of them to think about. Up, down, left, right, vertical, horizontal stretch, and reflection. Just those 7. But think about what they do. So let's put it all together. So what if we have a problem like this one? These are our last 2 that we're going to graph. Bigger. All right, first let's describe the transformation because that's going to help us make the graph that we have. So start off one part at a time. Y equals 2. Well, what does this 2 tell us? Vertical stretch. Good. Make sure you say vertical stretch of 2. You got to put all those words in there. When you describe your transformation, sometimes it can seem a little wordy. Now, after that 2, we have a square root, and inside the square root is x minus 3, which means it moves right 3. Then we have a plus 1, which makes it move up 1. So describe all of those numbers. So there are 3 different numbers in there, the 2, the 3, and the 1, and there's the description. Now, let's make our graph. First thing you should do is the up, down, left, right. So we're moving right 3, up 1. That's my starting point. And then a vertical stretch of 2 means it just goes a little higher on that kind of takeoff. So go a little higher and then make it go up and over. Now let's figure out our domain and range, but before we do that, we can write the coordinates of this point, our starting point. The coordinates are 3, 1. So our domain, x is, and range, very good. So 3, 1, greater than or equal to 3, greater than or equal to 1. Is this pretty simple so far? Pretty easy so far. Okay, good. Should be. If you struggle with something, though, let me know. Happy to help. All right, last graphing one. We have y equals negative 1/2 square root x minus 1. Now, when you start off with a negative and a number, you have to split those in your brain, okay? So the negative is like, say, a negative 1 times 1/2. And then we have our square root of x minus 1. So keep the negative separate from the 1/2. So what does the negative tell us? It's reflected. So the negative tells us it's reflected over the x-axis. What does the 1/2 tell us? It's a horizontal stretch. So you have to keep those two separate. So a negative and the number are two separate quantities, two separate things, okay? So if it was a negative 2, you wouldn't say a horizontal stretch. It would be reflected with a vertical stretch of 2, okay? So keep those two separate. Now, what does the minus 1 tell us? Good, right 1. So when we find our coordinates of where we start with, we're just moving right 1. So right 1 is our dot. We're going to start here. And then we have a horizontal stretch of 1/2, which means it's going to be shorter, but it's reflected, so it's going to flip. So it's a short flip for that graph. Now, if you are confused, graph it in y equals to see what it looks like to plot it. The main thing that I'm going to be looking for is this starting point, and then do you have it going in the right direction? And kind of the steepness as well, like exaggerate the steepness if it's a stretch or horizontal or vertical stretch. All right, so the coordinates of this point are 1, 0. There you go. X before Y. So our domain, X is, and the range, very good. So we moved right 1. So there's the 1. We didn't move up or down. So there's the 0. All right, now we've done all of our graphs, but there's one more thing that we're going to do. I'm going to give you a description, and you're going to write the equation. So we're kind of going to go backwards. So I'm going to give you this part, and you're going to have to write this. So here are the descriptions. If you want to go ahead and write those down. If you want to put them on notebook paper, you can instead of your graph paper. But if you only got graph paper, you can write them on your graph paper. It doesn't matter. And you can just save one line between each of these because we're just going to write an equation. So y equals. Oh, these words are interchangeable. I forgot this other book uses vertical compression. That's the same thing as a horizontal stretch. So those two are interchangeable. Vertical compression, horizontal stretch, same thing. It's kind of like a rubber band. If you stretch it vertically, it's going to get really skinny. But if you compress it down, it's going to end up going out this way. So like a horizontal stretch. So either way will work. All right, let's go ahead and write some of these equations. So if it is translated up 3 and right 2. So we're going to start with y equals, and I'm going to make a big square root. But something's going to be inside that square root. What's going to be inside? Minus 2 to make it move right 2. And on the outside, I would put plus 3. Very good. And that's it. That's what we do to write our equation. So it's got to have a square root in it. Oh, it will say write an equation for y equals square root x. So if it was multiple kinds, it'll tell you like the parent function at the beginning. Yeah. All right, so number 2, vertical stretch of 3 reflected over the x-axis and translated left 7. So I'm going to start with y equals. What's going to come first? Negative 3. Very good. The negative for the reflect, the 3 for the stretch, and then square root of x plus 7 since it moves left 7. So the opposite inside that square root. Very good. Okay, question 3. Vertical compression, also known as horizontal stretch, of 1/3, translated right 1 and down 5. So y equals 1/3 and then minus 5. So remember, the up, down is what you think. Down is minus, up is positive, but inside that square root, it's opposite. All right, last one. Reflected over the x-axis and translated up 4. So y equals. Good, and the plus 4 on the outside. All right, so now it's time for you guys to work on your homework. I forgot to hole punch them, so I'll do that in a second. So on here, I actually made little graphs for you, so you don't have to have graph paper. But the tick marks, the extra grid didn't show up because it was too thin. So make sure that you write tick marks. So on your paper, you have this, but I want you to go through and put like right 3 up 2 and then put a dot however it's supposed to be. So make sure you make tick marks. You can even write on there what the numbers are if you need to. Okay, and it says describe the transformation, sketch, and state domain and range. So the first page is like what we've been doing with our graphs. On this page, it says you're just matching the function with the graph, but then it says also state the domain and range. You can write them down here at the bottom if you want to, or beside the numbers. And then on the back, you're completing the table. It's a function, a graph, domain and range, and description. So you're going to fill out for the parts that you need. Does that make sense? Okay, so just a reminder about a few things real quick while I hole punch these and then pass them out. After today, we're only meeting in this class 25 more times. So remember, that's 25 more times to help increase your grade. Next week, I'm staying after for tutoring on Monday and Thursday until 3:45 because there is a good amount of people who need to make up tests and quizzes. So if you can stay after one of those days and get some things done, you can. Or if you want to stay after for some extra help, then you can do that too. Of course, I'm here every morning from 7:50 to 8:15 to answer any questions that you have. And then, during class, you end up having at least 30 minutes. Today, you only got 30, but I think the homework's pretty quick. And test is coming up on Tuesday, okay? So make sure you study a little bit over the weekend to get ready for the test. And the best way to study math is to look back at homework and notes and do it. So the best way to study math is to do it and practice.